So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 281, and in this video we continue with our copy constructor. We stopped here and let's read the sentence. The copy constructor is called whenever an object is initialized from another object of the same type, which includes, and then we have here the initialization process with which is, this one is a copy initialization and this one is a direct initialization. And this example we already saw here down. Let's go here. You can see we create first an object and then they use here direct initialization, but they are creating here an object, then they pass here the argument directly in it, and then the copy constructor is called here at this point. And then the same thing goes with this one. Here they create an object, they create here another object, and while they are creating this object here, they initialize it with copy initialization, which is this object B here will be copied to here. And in this case, the copy initialization, the copy constructor is called too, but be careful about this equal sign here, that you not make the mistake with this one here, which I show you now. Again, I have here a struct A, and now I create here an object with this A, but I'm not initializing anything here with another argument, with another object. And here the same thing, I just create an object. And after I created both object, now I say, hey, I want to copy all the things from object 2 to object 1 so that they are both. This is also more or less something like a copy. It's not called copy. And then you can see how I can make this one here. I just say, okay, object 1. Copy all the values from here to here, and here we have an assignment operator. This here is actually calling the copy assignment operator, not the copy constructor, and that is very important to distinguish. And the reason for that is because if you have here a user-defined copy constructor which has here special settings, you will not see them because this one is not copied. So that's that. And let's go here to the next thing, which says the copy constructor is also called when we have a function argument passing. And we already know three ways of argument passing. One way is passed by value, passed by reference, passed by pointer. And actually the copy constructor is only called when you pass by value. Then the copy constructor calls by a reference, it's not calling. And actually passed by pointer, the copy constructor copies still the pointer, but not the content which is pointing to. So careful about this one. But we learn now it is called when you are passing value. And what does mean? Here I have again a little example. Here's a function. We have a return value. Here is a parameter, no reference, no pointer. So I pass by value, and at this point the copy constructor is called and will copy all the values what you are creating. So in my case, I created here a number and I passed it in as an argument. This number here is copied here as well. So why is this important to know? Because if you have an int object like me, there is no problem actually with passing by value because there is no performance cost. But if you have a big class which is allocating memory and thousands of files or whatever, then creating here a copy is a performance cost, because think about it, you are allocating again all the memory which was already coming from. And that's why they say if you have a big class, use pass by reference or even pointer, but not by value like this one, because by value means all time it is calling the copy constructor, is creating all things again. And this here goes even worse. Why? Because the return value here is also creating a copy, and that is the next line here. It says here function return A creates also a copy, not all time. When you have something like a move constructor, which we will talk also in one of the other videos, then it is not creating a copy, but in general it can create a copy. So you see a function is really heavy actually when we use pass by value and with a return time, because it's all the time calling the copy constructor again with primitive types like this. It's not heavy, it's no problem. But if you have a big class with allocated memory, then it is performance heavy. All right, with that said, let's go here a little bit more further. Here, all this kind of stuff you already read. I hope it's more or less the explanations and other things like that. But here is one more important note, and it says here, in many situations, copy constructors are optimized out. So the compiler can decide later, because the functions you see is a big problem if you have here a class. And the compiler can say, okay, I know a better way how to make this. Instead of copying a copy constructor, I can solve this internally and not calling a copy constructor. And this goes here too. And we have to be careful here, because compiler and compiler differs, because not all compilers are the same. Some optimize it this way, some optimize it that way, but this is advanced topic, so we skip this. The only thing what you have to know is that the compiler is optimizing, and then it is not calling the copy constructor even we expect it to. And why is this so a problem? Because if you have there observable side effects in your copy constructor, but what means this observable side effects actually? So let's say here is a copy constructor, a user-defined copy constructor. The job of the copy constructor is just to create a copy, no more, no less. This is not a side effect. But what is a side effect? A side effect is if I go here now to this body and say you have another, you should do other things as well, not just create a copy. And all the other things are side effects. For example, they say here observable side effect would be, for example, you say, hey, when this copy constructor is called, print this on a log or print this on a screen. And now you can see that this side effect, this is just printing on the screen that this copy constructor is called. And they say here, this one here is not called, even if you have defined it here, because the compiler can still optimize it out. Because the compiler is all time priority, not what we are doing. All right, that's very important. Again, compilers are one topic that we skip here. You have to know it. If you make something like in your copy constructor and you expected that the copy constructor is here called or here, careful, the compiler can optimize it out and it is not called. Normally it's good that the compiler optimizes it out, because you are creating not a copy. All right, and in the next video we will talk about these examples and talk a little bit more about this sentence here, which means how it is copied. So how you copy this from one to another. Then we talk about the shallow copy a little bit and deep copy, and make an example here what deep copy is. All right, with that said, if you have any questions, like all time, write in the comment sections. See you in the next video. Bye and good luck, and like all time, have fun.